I am Carol Wynn Whiteman, and today we are going to be looking at some problem-solving strategies. Now, I know that your teacher probably explored some of these with you, but today we are going to delve deeper into some other problem-solving strategies. So, I'm going to give you a few moments for those of you who do not have your notebooks and pencils ready to go and get those implements while we prepare. Now, the first thing I want you to notice is that we are using Polya's problem-solving steps. There are 4 steps. The first step is to understand the problem. How do we go about understanding the problem? Well, you need to read. Maybe the first time you read it, you didn't fully comprehend what the question was asking. So we might have to read it a second or third time. Say aloud what you are trying to find. Underline the important information in the problem. Let's go through again. The first step is that you must understand the problem. Secondly, having understood the problem, we must now devise a plan to solve the problem. Now here, there are 8 different methods that you can use. You can draw a diagram, maybe use smaller numbers. How about acting it out? Working backwards. Guess and check. Yes, that is also a strategy. You can guess and check. You can make a list or table. Sometimes there is a pattern. You may have to look for a pattern. And guess what? Good old common sense and reasoning is also a strategy. Having understood the problem, devise a plan, our third step is to go and carry out the plan. You have to use the information that was given in the question. Maybe the strategy you chose was not the most appropriate one. So you may have to choose another strategy. Finally, you have to check back. Ask yourself, does my answer make sense? Maybe you have to review the computation, your addition, multiplication, subtraction, or division. Did you use the correct unit? And finally, did I answer what was asked? Let's go over the 4 steps again. 1, understand the problem at hand. Devise a plan. Carry out the plan and check back. Now we are going to look at a couple of questions and see which strategy would be best used for each question. So let's look at our first problem. Read aloud while I read it with you. 2/5 of a number is 18. What is the number? Remember, our 4th step says the first step, you have to understand the problem. So let's read it again. 2/5 of a number is 18. What is the number? Do we understand what the question is asking us? The number, obviously, has to be more than 18. Let's go. Which strategy do you think would be the most appropriate one to solve that problem? Would you draw a diagram? Use smaller numbers? Act it out? Work backwards? Guess and check? Make a list or table? Look for a pattern? Or use common sense and reasoning? Again, I'm giving you a chance to go through the strategies to devise which one will be most appropriate. I have draw a diagram. Did you come up with that one? Yes, let's see. I am going to draw a diagram. The question says 2/5 of a number is 18. So let's see. 2/5 tells us that our whole is divided into 5. So let's draw our whole. I am going to divide this box into 5 equal parts. That's my 2/5. 2/5 is 18. So that tells us 1/5 and 2/5 would make up 18. What can you figure out from this? If 2 of them make 18, then 1 would be 9. Not so? And if each one is 9, we can conclude that each of the other pieces will also be 9. Let's do that over. The sum says 2 out of the 5 parts is 18. So we use the strategy of drawing a diagram. We drew a diagram to represent the whole, divided the whole into 5 equal parts, and shaded 2, because the sum said 2 out of the 5. If 2 parts equal 18, then 1 part will be 9. Then each part of the whole will also be 9. But what does the sum ask us? The sum asks us, what is the entire number? So we now have to add 9 5 times, or multiply 9 by 5. 9 times 5 is 45. So the number is 45. Let's see if we followed all the steps. We understood the problem, we read the problem, we chose a strategy, draw a diagram, we carried out the plan using the information that was given. So let's do our 4th step. Let's check back to see if our answer makes sense. So we're going to work out 2/5 of the number, which is 2/5 of 45. 5 into 5, 1. 5 into 45, 9. 2 times 9 is 18. So we have checked back to make sure our answer is correct. So if 2/5 of a number is 18, what is the number? Then the number will be 45. So let's look at our second problem. Again, the first step says we have to understand the problem by reading it. So you read aloud at home while I read it here. Rhea has 229 stickers. Her sister, Marla, has 68 fewer stickers. How many stickers do they have all together? Let's read it again. Rhea has 229 stickers. Her sister, Marla, has 68 fewer stickers. How many stickers do they have all together? Let's go back to step 1. Step 1 said, read, say what you are trying to find, and underline the important information. So let's do that. Let us underline the important information. The first piece of important information is that Rhea has 229 stickers. Her sister has 68 fewer, which means her sister Marla has less. The question asks, how many do they have all together? This word all together tells us that we have to add or sum Rhea's total with Marla's. So we have done step 1. Let's go to step 2. We have to devise a plan. Which of these strategies do you think will be most appropriate? Remember that there can be more than one strategy to use. Again, I'll give you a few moments to go through the strategies while you think which one will be most appropriate. Let's see. Draw a diagram. Make a table. Did you come up with that? Remember, there can be more than one correct answer. Let's start with make a table. The first piece of information, we have two sisters, Rhea and Marla. So I am making my table. The sum says Rhea has 229. So under Rhea, I am going to write 229. Marla has 68 fewer, which means that from the 229, I am going to subtract 68. Let us see how many Marla has. 9 take 8 is 1. 2 cannot take 6, so I'm going to take 1 from the hundreds column and convert it to 10 tenths. So that 12 take 6 will give me 6, and 1 take nothing is 1. So Marla has 161, which is 68 less than Rhea. The question asks, how many stickers do they have altogether? Altogether tells us we have to add Rhea's 229 and Marla's 161. Let's add 9 and 1, it's 10. 2 and 6, 8, and 1, 9, 2 and 1, 3. So altogether, they have 390 stickers. So we have carried out the plan. Use the information that was given. Would another strategy be more practical? What about if we drew a diagram? Let's see. We are going to now do that same problem using the bar model. So here we go. We are going to draw Rhea. She has 229. Marla has 68 fewer. So I'm going to draw Marla's a little smaller. This amount here would therefore be 68 for Marla. So let's work out how much Marla has. Marla will have 229 minus 68, which we saw was 161. So Marla has 161. So altogether, 229 and 161, which comes up to 390. The same answer that we got. Can you think of another method of solving the same problem? Let's see. What if we drew Rhea 229 and drew 229 to represent Marla, but take off 68. So I'm going to remove that 68. So what did I actually do? I had 229 once, 229 twice, and when I added that, 9 and 9, 18, 2 and 2, 4 and 1, 5, 2 and 2, 4. But then I have to remove 68 because Marla has 68 less. Let's see. 8 take 8 is 0. 5 cannot take 6, so I'm going to take 1 from the hundreds column. 15 take 6 is 9. 3 take nothing is 3. So what have we done? We have shown 3 different ways or 3 strategies of solving the same problem. Remember, each question can be solved in a variety of ways. The first method was making a table. The second way, we drew a diagram. And the third way also involved drawing of a diagram, but in this method, we added 229 and then subtracted the 68 to get 390. So we have done step 1, step 2, and step 3. So let's check and see if our answer makes sense. Let's see. Altogether tells us that we have to add. So our total must be more than Ria's 229 and Marla's 161. Review the computation. We're just going to check back to make sure that our subtraction and addition were correct. Did I use the correct unit? Yes, the unit in this sum was stickers. Did I answer what was asked? Let's see. The question asks us, how many stickers do they have all together? So did I add Ria and Marla's total? Yes, I did. 390. Therefore, my answer equals altogether they have 390 stickers. So let's have a look at this third problem. Again, we are going to follow the Polya's problem-solving steps. Step 1, understand the problem. So we're going to read. Read at home while I read aloud with you. Mia used 8 meters of ribbon to make bows. She used 36 centimeters to make each large bow and 12 centimeters to make each small bow. She made an equal number of large and small bows. If she has 32 centimeters of ribbon remaining, how many bows did she make altogether? So we're going to read it again, just to ensure that you understand the problem. Mia used 8 meters of ribbon to make bows. She used 36 centimeters to make each large bow and 12 centimeters to make each small bow. She made an equal number of large and small bows. If she has 32 centimeters of ribbon remaining, how many bows did she make altogether? Let's move on. Say what you are trying to find. What are we trying to find out in the question? Well, we know she's making large and small bows. We want to find how many large and small bows she made in all. Underline the important information. What's the important information here? Mia started out with 8 meters of ribbon. She used 36 centimeters for each large bow and 12 for each small bow. Another critical piece of information is that she made an equal number of large and small bows. Finally, she remained with 32 centimeters of ribbon. Let's move on. Which of these strategies will be most practical? A diagram, using small numbers. Possibly, if we had ribbon, we can act it out. Work backwards. Guess and check. Make a list. Look for a pattern, or use common sense and reasoning. Giving you a minute for you to think which one of these will be most practical. Yes, using common sense and reasoning. So let's carry out the plan. Let's use the information that is there. First step, you realize that we started off with 8 meters, but all our other units are in centimeters. So the first thing I would like to do is to change my 8 meters to centimeter. So Ria started off 8 meters, which is 800 centimeters of ribbon. If she has 32 centimeters of ribbon remaining, then common sense will tell us that she used 800 less the 32. So let's see how much Mia used. 800 less 32. 8, that's a 7 to the tens column. That is an 8, 6, 7. So it means that Mia used 768 centimeters of ribbon to make the large bow and the small bow. What else? Keyword, she made an equal number of large and small bows. Therefore, every time Mia used ribbon to make a large and a small bow, she used 36 centimeters plus 12 centimeters, which gives us 48 centimeters of ribbon. Let's do that over. Since Mia used 36 centimeters to make a large bow and 12 centimeters to make a small bow, every time she cut ribbon to make a large and small bow, she would cut 48 centimeters of ribbon. So 48 centimeters will give us 1 large and 1 small bow. But we are not finished. The question asks, how many bows did she make altogether? She used 768 centimeters of ribbon. Therefore, we must now take that 768 centimeter and repeatedly subtract 48 centimeters. Now we know repeated subtraction is division. So we are now going to divide 768 by 48. Let's see. We are going to try 8. 8 into 48 is 6. 8 into 76. 9 8s is 72. Remainder 4. And 8 into 48 again is 6. 6 into 6 is 1. 6 into 9 is 1. Remainder 3. And 6 into 36 is 6. Which means that Mia did 16 sets of ribbons. But each set has 1 large and 1 small. Therefore, she made 16 large bows as well as 16 small bows. Did I answer what was asked? No. The question asks, how many bows did she make all together? So that tells me I have to add. So all together, she made 32 bows. So let's go to step 4. Does my answer make sense? 32 bows. Let's review the computation. We check back to ensure that our subtraction is correct, that our addition is correct, that our division is correct, and finally, our addition is correct. Did I use the correct unit? Yes, we are talking about bows. Our unit for this question is bows. How many bows did she make altogether? And finally, did I answer what was asked? Yes, I did. The question asks, how many bows did she make altogether? Not how many large bows and how many small bows, but in total, how many did she make? Altogether, Mia made 32 bows. We have another question on the board. Again, we're looking at step 1, which is to understand the problem by reading it. So we're going to read this question. 15 marchers are standing in a straight line equal distance apart. If the distance between the second and fifth marcher is 12 meters, what is the distance between the fourth and 12th marcher? We're going again. 15 marchers are standing in a straight line equal distance apart. If the distance between the second and fifth marcher is 12 meters, what is the distance between the fourth and 12th marcher? So we are going to say what we are trying to find. We are trying to find how far apart the 12th marcher is from the 4th marcher. Let's underline the key information. It's 15 marchers. Very critical to the sum, they are in a straight line equal distance apart. We know the distance between the second and the fifth marcher is 12 meters. So which of these strategies do you think will be most appropriate? Drawing a diagram, using smaller numbers, acting it out, maybe working backwards. What do you think? Guess and check? A list or a table? A pattern? Or common sense and reasoning? You tell me, which of these do you think is the most practical method? Did you guess draw a diagram? Yes, that will be the most practical strategy for solving this. So let's go on to step 3. We are now going to carry out the plan. So let's draw our marchers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are our 15 marchers in a straight line. Now the distance between the second and fifth marcher is 12 meters. So let's go. First marcher, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15. Let us identify the second and the fifth marcher. So the distance between the second and fifth marcher, this distance is 12 meters. What does that tell us? There are, in fact, 3 spaces between the second and the fifth marcher. So if there are 3 spaces, and those 3 spaces equal 12 meters, then one space will be 12 meters divided by 3, which is 4 meters. Be careful, because you may think from 2 to 5 there are 4 marchers. So you may want to believe that there will be 4 spaces. But this is where the diagram comes in very critical. If there are 4 marchers in a straight line, there will only be 1, 2, 3 spaces. Those 3 spaces add up to 12 meters. Therefore, one space would be 12 meters divided by 3, which is 4 meters. Let's move on to the next step. The question asks, what is the distance between the 4th and 12th marcher? Remember, the marchers are equally spaced. So let's identify our 4th marcher, which is this one here, to our 12th marcher, which is this one here. So let's count how many spaces there are from our 4th marcher to our 12th marcher. Let's start. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 spaces. Let's do that again. From our 4th marcher to our 12th marcher, they are in a straight line, so we are counting the spaces 1, 2, 3, 4, 5, 6, 7, 8. This is where drawing the diagram is so useful. But remember, they are equal distances apart. Therefore, each space will be 4 meters. Yes, 4 meters each space. So I'm going to just put 4 meters on each space here. It means, therefore, that we have 4 meters 8 times. So from the 4th to the 12th marcher, from 4th to 12th marcher, there are 8 spaces. Therefore, the distance would be 8 spaces times 4 meters, which is 32 meters. Let's see. We are now on to step 4. Does my answer make sense? 32 meters between them. Let's review the computation. Is my division correct? 12 divided by 3 is 4. 8 times 4 is 32. Did I use the correct unit? We are working in meters. Did I put my answer in meters? Yes. Did I answer what was asked? The question asks the distance between the 4th and 12th. So from marcher number 4 to marcher number 12. The question did not ask from the 1st to the 12th. It asks from the 4th to the 12th, which means we are only counting 8 spaces. And if each space is 4 meters, then that total distance will be 32 meters. Well, boys and girls, let us summarize what we have done today. We have gone through Polya's problem-solving steps. Step 1, understand the problem, and there are various methods you can go about doing that. Read it. Maybe you may need to read it more than once. Sometimes it will help to say aloud what you are trying to find. It is critical that you underline the important information in the question. Having done that, you will then devise a plan to solve the problem. There are 8 different strategies here. Draw a diagram, use smaller numbers, act it out, work backwards, guess and check, make a list or table, look for a pattern, use common sense and reasoning. I'm sure you have already been using all or some of these in your classes, but these are just some others that you can probably have a look at with some other questions. Remembering that a question may be solved using one or more of these strategies. Step 3, when you have devised your plan, you need to carry out the plan. Use the information given in the question. Sometimes another strategy might be more practical. Finally, you need to check back. Make sure, ask yourself, does my answer make sense? Put yourself in a practical situation. You need to review the computation. Many a times, a question is incorrect because of a simple mathematical error in addition, subtraction, multiplication, or division. Always review your computation. Check your unit. Did you use the correct unit? And finally, did I answer what was asked? Read the question again, find out what the question is asking you, and ask yourself, is my answer what was being asked for? So I hope these problem-solving steps were of use for you, and that in future, when you are stumped with a problem, you'll remember the 4 steps in solving problems. Goodbye.